tubular cell, tubular lobe. We call it alkali recovered, bicarbonate recovery. If we need to increase the pH, we have to recover the bicarbonate. It's a one mechanism by the key. Okay? And also we excrete the hydrogen. Then the second mechanism is here. We can excrete ammonium, okay, and actually hydrogen ion. By ammonia together as ammonia we can excrete, and we decrease the amount of H plus from our body. Is the second mechanism. And the third one is both the phosphate and also ammonia together. Here, HPO4 2 negative will filtrate. And again we have an exchanger for H plus, H combined with acid phosphate or combined with NH3. As an NH plus and as an acid phosphate, both of them can be excreted. We call it the net acid excretion. As a H itself here in the previous slide, we cannot excrete a lot of H plus directly. It's not in the previous slide. Okay? I don't know where is it located. This H plus directly. We can't excrete a lot of H plus. For this reason, we don't call it the net acid excretion. The net acid excretion is related to amount of NH4 and actually acid phosphorate, both of these. Because we can excrete a lot of H positive by these two compounds. So let's look at the situation here. We have a metabolic acidosis, the first one. In metabolic acidosis, bicarbonate concentration is decreased. When we have a decreasing in bicarbonate, when excessive amount of substance that are acidic or can be broken down to the acid are ingested. So this acid, they produce H plus, H positive. H positive combined with the bicarbonate and use this bicarbonate. And bicarbonate act as a buffering for this H positive. So the amount of bicarbonate decrease. For example, in those people they use wood alcohol, methanol. It's so dangerous because lead to the decreasing in the blood pH and lead to the death. Antifreezing, ethylene glycol, also is so dangerous compound. Large dose of aspirin, acetic salicylic acid, also lead to the death. All of these situations are so dangerous. And sometimes we have a metabolism abnormal. Maybe due to the diabetes mellitus, maybe due to the starvation. We produce a lot of keto acid and actually lactic acid. And these two acids, they lead to the using bicarbonate and they are known as a metabolic acidosis. Yeah, ketoacidosis also is another. And they lead to the actually inability to excrete hydrogen ion from the kidney. So when we have a metabolic acidosis, bicarbonate is decreased. How we can manage it? If you remember the formula, Anderson-Hasselbalch, bicarbonate on the top,
and
CO2 should be decreased or increased?
If we have to what? If you have
Decrease.
Yeah, exactly. CO2 decreased. We have to decrease the CO2. By what? By increase the rate of breathing and reduce the amount of CO2 in the blood. What is the name of this? We call it respiratory alkalosis. In respiratory alkalosis, we have a decrease in CO2.
Is there,
So for compensatory of metabolic acidosis, we have to do
Respiratory alkalosis.
respiratory alkalosis. Yeah.
is there a relation between the CO2 concentration and the pH?
Exactly.
If we have like high concentration of the CO2, the pH gonna be
Low.
increased.
Decrease.
Why? Should be increased because
No.
down to form carbonic acid, right?
No, when we have increasing CO2, okay,
Yeah.
CO2 by H2O convert to the H2O.
Carbonic acid.
Yeah. H2O plus CO3 is a carbonic acid. Is acid.
Right.
Is an
So,
acid.
yeah, it's acid.
Yes.
So pH should be.
Degrees.
And also it can digest to the H plus, and H plus also is increased. It's acid.
Yes.
So CO2 is a carbonic acid. And when it's increased, it means acidic situation is increased.
Yeah.
Oh, I have a question.
So let's look at this situation. First, pH is a 7.32. What is the situation? Is acidic or basic?
Acidic.
Acid. Okay, A. So we have A here. PCO2 is a 32. PCO2, actually, normal range of CO2 is a 35 to 45. And the medium is a 40. Okay? What?
So it's normal to almost.
Less.
It's a
No,
little
it's
less.
not normal.
It's a little less.
40. Imagine 40.
It's less.
Is less. So CO2 is decreased. About bicarbonate. Bicarbonate is 22 to 26 and the normal is 24.
Also decrease.
So bicarbonate decrease, CO2 decrease, pH decrease. So what is the main reason?
Main reason for which one?
Okay. You know pH is low.
Mm.
Yes.
When pH is low, it can be due to two reasons. When pH is low, it's due to two reasons. Maybe CO2 is increased, maybe bicarbonate is decreased. Okay?
Yes.
So,
Here we have
which one happens?
CO2.
Which one has happened?
Degrees.
Bicarbonate is decreased.
Both of them are
CO2.
decreased in this situation. Okay?
Yes.
Let's. Which one is the first?
CO2.
CO2 is the first.
No, bicarbonate is the first because bicarbonate is more decreased, and that's why we have a decrease in pH.
You didn't get.
No.
It means when we lost like oxygen,
No.
we got CO2.
Yes, you are.
No, when blood pH is too low, either we have too much acid, which is CO2, or we have too little base, which is bicarbonate, right?
Yeah.
So we have the pH is low. Both of the values of CO2 and bicarbonate have decreased, but because the pH is, it's more acidic, then obviously the bicarbonate, the rates or the degree of decrease of bicarbonate is much higher than the decrease of CO2, which is why it had a larger effect.
And just look at it easily, not too much complex. Here we have a decreasing pH.
Yes.
Okay? The main reason of decreasing in pH, it can be increasing CO2 or decreasing bicarbonate.
Yes.
Okay. We have a
So,
Degrees in CO2.
so is the increasing of the CO2? What's the factor that gonna increase CO2? Is it like a respiratory factor?
we will talk about it in the next one. Just let me do it. When we have actually metabolic acidosis, we have a decrease in bicarbonate. So when we are going to compensate, to correct, to compensate, what we should do?
We should also
First have CO2.
Decrease the CO2.
CO2.
Okay. If we have a pH increasing, it can be due to the decreasing in CO2 or increasing in bicarbonate. So this situation, they are easy because we know pH is decreased. When pH is decreased, bicarbonate decreasing or CO2 increasing are the first outcome. Then for compensation, we have a decreasing in CO2 or increasing in bicarbonate. So because the bicarbonate is decreased, we have a decreasing in PCO2. Is the next, is the second for the compensation. Okay? We will talk and we will learn, don't worry. So the first outcome is decreasing in bicarbonate. The second outcome is increasing and decreasing in CO2. And if you look at them, it's acidic, CO2 is basic, bicarbonate is acidic. So they are in the same side, in the same direction. But here is in opposite. It's for compensation. You got it?
Yes.
We have an acidic pH and actually bicarbonate, CO2. Because it's acidic and bicarbonate is acidic, it means the first bicarbonate decreasing is happen, then our body decrease the CO2 to increase the blood pH. But is known as a partially compensate because the pH still is acidic.
And the CO2 is still less than the one. The partial pressure of carbon dioxide is less than how it should.
Exactly, it's decreased
Yeah.
for the compensation. They are so easy. When the pH go back to the normal, it's so difficult to decide which one first increase or decrease the other in response to that decrease or decrease. When the pH is low, it's good. It's completely clear. So we call it partially compensated metabolic acidosis. Why? Because there is evidence of compensation and because the pH will remain below the normal range. We call it partially compensated metabolic acidosis. So you got it completely here? Good.
But we said the CO2 is acid. Why is base?
Okay, CO2 when is increased lead to the acidic condition, when decreased lead to the basic condition.
Okay, here.
CO2 is decreased. So the main actually causes of metabolic or non-respiratory acidosis. One of them is ketoacidosis or increasing H positive formation. It's due to the diabetic or alcoholic, lactic acidosis, some poison like ethanol, ethylene glycol, and salicylate, and actually inherited organic acidosis. Methylmalonic acidosis, phenylketonic acidosis, or other metabolic disease you learn. Maybe acid ingestion we have. Excessive actually administration of amino acid, arginine, lysine, and PCB. Decreased H positive excretion due to the renal tubular acidosis and carbonate dehydratase or carbonic anhydrase entity. And losses of bicarbonate due to the diarrhea and pancreatic and intestinal fistula. So all of them, they lead to the metabolic acidosis. So metabolic acidosis can be present in two forms. If you remember from the previous slide, we had a term which is known as the onion gap. What was the onion gap?
It's other minerals. that we don't count?
Yeah, exactly. Is one of the reasons that lead to the losing of actually.
Unmeasured.
Let's need to bring the anion gap. The sum of cation and the anion in ECF always they are equal. So the sodium and potassium together account for 95% of the cation, but chloride and bicarbonate are equal to 86% of anion. And we just measure this electrolyte. The differences between this cation and anion which they are measured, we call it unmeasured anion or anion gap. These differences between sodium, potassium, and chloride and bicarbonate is equal to 12 millimole per liter, usually. Is the anion gap actually sodium, potassium, chloride, bicarbonate. But sometimes we have an increase in anion gap. And sometimes we have a decrease in anion gap, both related to metabolic acidosis.
What's the anion gap?
Anion gap. You know, here you were absent in the previous class for this reason.
Yes.
We have electrolyte, cation, and anion. For in our body, the amount of cation and anion are equal in plasma. In the plasma, the main cation is a sodium with 140. And also we have potassium just 5. Okay? These two, potassium and sodium, are the main cation. Here in the anion, we have a chloride and bicarbonate. Sodium and potassium, for example, they are near to 140, 145, exactly. Chloride and bicarbonate, they together are equal to 130, 32. The differences between the amount of chloride and bicarbonate and sodium and potassium is equal
Concentration
to
is
12.
difference?
What?
Concentration difference?
Yes, concentration differences.
Okay.
Is equal to the 12. And these 12 are those anion we don't measure. What they are? Protein, sulfate, phosphate, lactic acid, pyruvic acid, the other acids which we don't measure. Usually they are 12. When we have a metabolic acidosis, we have increasing in this acid. And we call it metabolic acidosis with high anion gap. High anion gap metabolic acidosis. Sometimes we have a metabolic acidosis with normal anion gap. Why is normal? Because chloride is decreased. I will talk about it in next slide. In metabolic acidosis, actually, the concentration of H positive is increased, the pH is decreased, CO2 is decreased, bicarbonate decreased too much. They are the metabolic acidosis. And for management, you can study